In this very short video, I'm going to demonstrate one of the most significant changes that we just put into the next patch set for Smugglers of Cygnus Alpha 1. This will be going into the patch set 5, and the main change is we're enabling the Godot long double for higher map accuracy at extreme distances. I consider this to be pretty vital for space games, and so I'm going to show you what it does, why it does it, and how you fix it. Okay, so first off, let me show you what the actual effect is. We're not going to go into any math or any complicated stuff like that. I'm just going to show you what the actual visual effect is. Here we have a spaceship model. It is stationary, and it is approximately 10 times farther from the zero origin than the recommended maximum map size. Okay, so the recommended map size is 4 kilometers, which is pretty good size, and we're currently at 80 kilometers. So there's a chance to go ahead and see what that does. So I'm going to do that right now, and you'll see when it's stationary, it's not really too bad at all. But if we apply any kind of motion, if I rotate the ship, you see how it shakes quite violently. This is because at this range, it's essentially like funking between locations, right? So you're simply off the end of what it can accurately calculate. I'm not going to go into complicated math, but basically you're at the end of the float size. So if we accelerate, you'll see that now, even simply accelerating, I have really obnoxious jitter. And this is simply caused by being a long ways from the map's 0 point. So to demonstrate how far from the map's 0 point we actually are, let me go ahead and turn around. And if you look back here, that space station is the 0 point. So in a space game, this isn't very far away. We're close enough that we can still see it, and it's still fairly obvious. And I mean, I didn't even use like realistic distances. This is only 80 kilometers. If I was using realistic distances, you'd still be inside the atmosphere of a planet. So this is just using, reasonably large distances. So you can see here that it's quite dramatic how shaky it is. I mean, I would call it marginal as far as playability. The only reason we allowed it to actually get this far is partially because proof of concept, but mostly because in the third-person mode, when you're not confronted with a mesh right up close to the camera, it's not so bad. So now I've cut to the new build. This is using the long double and the recompile. Just by the simple act of recompiling Godot to use the same 4.2.2, but now with a long double, and then compiling the new export templates to match, I have, as you can see, completely eliminated that shutter. Because now it can easily tell, jitter, because it can easily tell the difference between the locations, and it's got a lot more to work with. So you can see we're even farther away now than we were in the previous one. I'm all the way up where the planet is. And there's absolutely no sign of shaking or violence, and I even went to a faster ship, so we're actually even moving much, much faster. And I even just ran into it there. We're moving much, much faster than we were, and with no effects from it. We can now easily get out to the moon without anything shaking. And we can see the lighting coming off the planet. Everything's smooth. Everything's working just like it should. No problems with the ray tracing. Nothing. Everything is smooth as silk. So as you can see now, we're even further out than we were previously. We're now all the way to the moon on the backside. The station is now all but invisible. And it is completely smooth. No shuddering or whatsoever. And this is entirely due to recompiling it for the long double, which gives you a lot more precision at extremely large map sizes. Okay, so now let me just go over the steps required to compile Godot 4.2.2 for double precision. This is covered pretty nicely in the documentation, but it's a little bit spread out and a little bit hard to find. So what I've just done is consolidated it all down to a very simple set of steps. And I will put this up on our forum as well, in case anybody finds this of use. So effectively, for a Linux environment, you prepare your environment, you go ahead and you update, you install the necessary components that you'll need to compile Godot. You will then need to also add the MingGW, and you'll have to switch to the POSIX version in order to build your Windows template. Then you just go ahead and you make your new directory, create your new key if you're going to be using signing, which you might as well use signing at this step since you have to recompile it anyways. Go ahead and clone the version that you're looking for. In my case, I was specifically getting 4.22, but whatever version you're looking for. And then when you run the build, you're going to go ahead and set it up. Now, there's two export environment variables depending on which document you're reading. It seemed to me that the script AES 256 was the correct one, but you might as well just export both to make sure that you're safe. And then you run the scons. You set your platform for the Linux BSD. You set it to use LLVM. And this is the important part. You set your precision equals double. And this part is absolutely consistent, whether it's Windows or Linux, you want precision equals double. That's where all the magic is. This just gives you 4 threads. And then once that's done, and it's reasonably quick, then you're going to go ahead and you're going to do the template. For the template, all you do is you add the target template release. This makes the version that you can distribute. Production equals yes, arch equals x86-64. And then for the Windows version, you're going to set the platform to Windows instead. And you're going to set the bits equals 64 and the tools equals no. Shouldn't be a space there. And the tools equals no. And that will make sure that everything is the way it needs to be. And I have tested both of these. They work just fine. It was a little confusing as to how to actually get it to use these. I found the best method was to just simply put these files in a location where you can find them and then point Godot at the build template executable files when you're building the appropriate template. And then you can go in and you can do anything that you need to set it up to make it friendly for Windows with RC Edit, things like that. So that's what we did, that's what we found, and that's how it looks. So in patch 5, it'll be a lot smoother, and I think a lot more playable, for people who like to play in first-person mode. Well, thank you very much.